Hi everyone, Mr. Mash here. In this section, we're going to go through this very interesting topic on elasticity. And the main focus of this particular session is price elasticity of demand. I want to make sure you understand it first before we then discuss the other elasticities. Generally speaking, this word elastic means, is something flexible? Is it not flexible? Can you stretch it? Can it take back its form once it's been stretched? And when we come to economics, this is an extension of demand and supply. So we consider what we call dependent variable and independent variables. I'm going to explain these two animals just now, but generally speaking, when you talk about elasticity, I'll use an E to represent elasticity. We are looking at how sensitive a dependent variable is to changes in an independent variable. So we calculate this elasticity by taking the percentage. This is a sign for a percent, everyone knows it. Change, this is the Greek symbol delta representing change. I'll use dV to represent dependent variable. How sensitive is the change in the dependent variable to changes in the independent variable? So there's the percentage change, percent change in the independent variable. I'll use IV to represent an independent variable. So what is an independent variable? What is a dependent variable? A dependent variable is a variable that depends on another variable. For instance, consumption of households or individuals and income. How is the consumption affected by the level of income? When people get more money, do they consume more? Do they consume less? And by how much does that consumption change? So in this example, the consumption would be an example of a dependent variable because I have said consumption depends on income, which then makes the income the independent variable. Hence the income in this case is the independent variable. All right. So when we get to the price elasticity of demand, which I said is the agenda of the session, price elasticity of demand, I'm going to use ED to represent the price elasticity of demand. We have two variables. Try to think about it. Which one is the dependent? Which one is the independent? You have the price and you have the demand. Demand and quantity demanded are two different things, but in this section, I'm going to be using these two terms interchangeably. So whenever I refer to demand, just know that I'm referring to the quantity demanded, but I'll try to use quantity demanded as much as I can. The two variables that we have is the price and is the demand. The quantity demanded depends on the price. So when the price changes, the quantity demanded changes. It's remember the law of demand where we said the price and quantity demanded have a negative relationship. So when the price is going up, the quantity demanded is going down. The price is going down, the quantity demanded is going up. The question in this section now is by how much? By how much is the quantity demanded changing? Is it going to be a small change in the quantity demanded? Is it going to be a huge change in the quantity demanded when there has been a change in the price? All right. So let's look at two different scenarios. I'm going to put these on one graph. The idea is not to confuse you, but I want you to be able to compare the two graphs. So bear with me. I'll use different colors so that you can see exactly what I'm talking about. All right. Price is on this axis and quantity is on this axis. Let me first put this one. I'm going to make the first one step. Let me make it step. This is a demand curve, and I'm going to call this demand for a product A. I'm going to draw another one. Let me use a blue color, and I'm going to make it relatively flat. I'm going to call this one the demand for a product B. So these are two demand curves which I've simply put on the same graph. Go back to my white color, right? And then this, where they meet here, I'm just saying they are going to start off at the same price of 100. Okay, so let's assume that this is 100 rand. Since I'm in South Africa, we use rands here. And this is the quantity for both of them. When the price is 100, both of them are demanded a quantity of 1,000. So for a price of 100 rand, the demand for product A is 1,000 units. For a price of 100 rand, the demand for product B is also 1,000 units. Now, let's assume the price goes up from 100 to 105. Let's say now the price has gone up to 105. This is an increase. All right, then I'm going to do this here. You see, for product A on the red curve here, there is this small change in the quantity demanded. There's a small change in the quantity demanded, and I'm going to call this. Let's say it is changed to 990. But for product B, there's this huge change in the quantity demanded, and I'm going to say it has changed from 1,000 to 900. All right. So this is a small change for A, and this is a big change for B. What you can generally see from this graph is that for products that have a steep demand curve, a change in the price results in a very small change in the quantity demanded. If this happens, you can see it is not flexible, and hence we conclude that because the effect of a price change is very small on product A, we say it's inelastic, it's not sensitive. We say it's inelastic. And then for product B, this same change in price of only 5 rand results in this huge change. It results in this huge change in the quantity, and therefore we say it's elastic. So if the demand curve is flat, the demand is elastic. But if the demand curve is steep like this, the demand is inelastic. All right. How then do we calculate the price elasticity of demand? I'm going to show you 3 ways of calculating this. I'll start with the common way, which everyone uses and which is very straightforward. It's an extension of this formula. And this is the formula I'm going to be using for all the elasticities. You always put the dependent variable on top, the independent variable at the bottom. So the elasticity of demand, the price elasticity of demand, would then be the percentage change in the demand is our dependent, and I said this is quantity demanded, should be divided by the independent variable, becomes our price, the percentage change in the price. All right. This formula, so this is formula 1. Write it down. We are going to use it just now. This formula can be extended to, rather let me say simplified, to just the change in the quantity demanded, there's no percent here, divide by the change in the price, then you multiply by the original price, you divide by the original quantity. This is the second formula. And actually, this is my favorite one. I like this. It's quite quick and straightforward, but we are going to use both formulas in our calculations, right? All right. So quickly put these numbers down. The price has changed from 100 to 105. For product A, the quantity has changed from 1000 to, for A it changed to 990. And for product B, the quantity has changed from 1000 to 900 for product B. All right. So these are the changes that we have, and these are the ones that we're going to use in our calculation for the price elasticity of demand. Right. Let's get on it. Using the first formula, so let me keep these numbers up here so that you can see. Keep it here. I'm going to use the first formula, 1, where we have the elasticity of demand as the percentage change in the quantity demanded. You divide this by the percentage change in the price. How do we calculate percentage change? So this is important. For any percentage change, you're always going to take the new value. You subtract the old value or the original value. You divide by the old value or the original value, and you multiply by 100%. That's how you calculate percentage changes in whatever, whether they're asking you to calculate inflation, GDP growth, whatever. Percentage changes are calculated using the new value minus the old, divided by the old, multiplied by 100%. What then is the percentage change in quantity demanded? We're going to take the new quantity. Our price has changed from 100 to 105. So for product, let's do for product B. You guys will try product A. For product B, the new value for the quantity is 900. You subtract the old value for the quantity, this one, which is 1000. Then you divide by the old value, which is 1000. Then you multiply by 100%. This is a negative. 900 minus 1000, you get minus 100. And then this minus 100, you divide this by 1000, you multiply by 100%, and you cancel out things here. You can use your calculator if you get confused somehow, but this is minus 10%. In the percentage change in the price is, the new price is 105 minus the old 100 divided by 100 multiplied by 100%. This is 5 over 100 times 100%. It's a positive. We cancel this 100 and that. We have a positive 5%. Taking it back to this formula, we simply divide these two numbers. So our final answer is going to be the percentage change. So the elasticity of demand would be the percentage change in the quantity demanded. We got this is minus 10%, and the percentage change in the quantity, we get that as 5%. The percentages cancel out. Our answer should not have a percent. Remember that. They cancel out. And 10 over 5 is a negative 2. This is our answer for the price elasticity of demand. So you can pause the video. Try, I always get this complaint from my students that I speak too fast. But there's just always a lot to say. And time is a limiting factor. So, I always suggest to them, advise them to come ready for class. Practice these things when you are in class. We do it together. But luckily, this is YouTube. Pause the video, go through the stuff again, make sure you get it right, and then continue. All right, let me use my favorite formula too. And I also don't want to make YouTube videos too long because you guys will get bored. And yeah, already these things are a bit of a challenge as they are. I wouldn't want you to sit here for 30 minutes. All right, let's look at the second formula, which I said is my favorite. This is my favorite formula, which is just the change in the quantity demanded over the change in the price times the original price over the original quantity. The change is just the new minus the old. You just subtract the two. The new quantity for, remember, you're calculating the elasticity of demand for B. We are calculating the elasticity of demand for B. The new quantity for B is 900. The original one is 1000. The new price for both of them is 105. The old is 100. We multiply that by the original price, which is 100, over the original quantity, which is 1000. There are no percentages here. There are no percentages at all. And hence, you are going to have, if you subtract 900 and 1000, it's a minus 100 divided by 5 minus 105 minus 100, it's 5. You multiply by 100 over 1000. So this cancels with that. 10 over 5, it's minus 2. So we get negative 2 as well, which is the same as this. It's the same as this. And if you manage to get this, well done. This for me is less tedious, and it's actually quite more efficient. This is the one I use a lot, and it also comes in handy when you now do other functional forms which are not always just linear. But that's not what we do at this level. All right, but know this formula. All right, now I want you to try before I get to the third formula that I promised you guys, I want you guys to try do for product A. Do the elasticity of demand for product A, and then you're going to find that the elasticity of demand for product A is equals to minus 0,2. Hopefully you find this minus 0,2 using those two approaches. And when you compare the two, you ignore the negative sign. The price elasticity of demand is the only elasticity for which you can ignore the negative sign. You ignore the negative sign, and then the smaller one is elastic, is inelastic. The bigger one is elastic. You see, for A, it's minus 2. You take absolute value, which is 0,2. And if this number is less than 1, we say it's inelastic. But the initial one that we calculated together for B was negative 2. If we take the absolute value, it just means the positive value, it's equals to 2, and this is greater than 1, we say it's elastic. Right. So we conclude like we did initially when we drew the graph. We saw that the one for B was flat and elastic. The one for A was steep and inelastic. The last formula that I want to show you guys to calculate elasticity, the third one, only use this formula if you are specifically asked to use the arc formula. So it's called the arc formula or the average formula. So we are calculating the average elasticity of demand. All right. This formula looks a bit complicated and ugly because we are using averages and not percentages. Hence, the answer is the same whether you, whatever number you start from, whether we start from 105 going to 100 or from 100 going to 105, the answer should be the same. So this average formula, it looks a bit ugly because it looks something like this. You are going to take the change in the quantity, which will be the new quantity minus the old quantity or the original quantity, right? And then this answer here, you divide it by the average quantity, which is the quantity original plus the new quantity over 2. That's the average. Then you divide this whole thing by the change in the price, the new price minus the original price, divided by the average price, which is P1, P0 plus P1, that's an average, over 2. That's what it looks like, okay? But my advice to you, I will do another video to explain the math in detail. But my advice to you is to just write this formula like this. It's just the change in the quantity, like I've shown earlier, just the new quantity minus the old. You divide by the change in price and you multiply by the sum of the prices. So you multiply by the sum of the prices, you divide by the sum of the quantities. All right. So this P bar here is just P0 plus P1. This Q bar here is just Q0 plus Q1. All right. This is a very simple way of writing it, a simple way of remembering it, because it's similar to the one where I said use original price over original quantity. In this case, you're just using the sum. You can ignore the entire average because these twos, they are going to cancel out. They're going to cancel out. We use this. Let's do for product B. Let's do for product B. So the arc or the average elasticity for product B is going to be the change in the quantity for product B. The change in quantity for product B over the change in price for product B times the sum of the price over the sum of quantity. The change in quantity, we said, is just the new quantity, which was 900, minus the old one, which was 1000, the original one, divided by the change in price, which was 105, the new one, minus the original one, which was 100, multiplied by the sum of the prices, 100 plus 105, divided by the sum of the quantities, which is 1000 plus 900, right? And then we solve this. This was minus 100. This is 5 times. If you add these two, 100 and 105, you get 205. Add these two, 1000 plus 900, you get 1900. You can cancel this and that. So you have a negative 205 over 5 times 19. You put this in your calculator, you should get minus 2,16 to the two decimal places. The answer you get here must be close to what you got when using the first formula, the price elasticity of demand. Okay. Only use this formula when you're asked to use this formula. By default, we use the first formula, which is called the point price elasticity of demand. Whenever they say price elasticity of demand, they are referring to the point price elasticity of demand. All right. So again, this is greater than 1. This is greater than 1, and therefore the absolute value, which means the positive value, the absolute value is 2,16, which is greater than 1, gives us the same conclusion to say product B is elastic in demand. All right, so that's it for this session. Like I said, I want to make it too long, but for now, Mr. Mash is out. Cheers, guys, and have yourselves a lovely day. Happy studying.